All right, so let's continue. So I'm really privileged to announce this amount of knowledge on the stage. So next speaker is going to be Martin Taylor from Nimmy Incorporate from Toronto. And he's going to talk about design patterns for efficient multi-platform and multi-device testing with robot framework. Please, Martin.
Okay, thank you. Thank you, and good afternoon, everyone. So, here's what I'm going to be talking about. We're going to be talking not about my work at Nimmy, because I've only been doing that for about the last 6 months, and any of you that may know me through online connections, I was with Texas Instruments Education Technology Division for the past 14 years, and so it's work there that I'll be talking about today. So we'll talk about, what is that company, what is their product line, and a little bit about their approach to keyword design. And then I'll describe two problems, the multi-device testing problem that we had, and what kind of solution architecture and design we came up with to solve that. And then multi-platform testing, again, I'll describe the problem that we were trying to solve and the architecture and design for that. I have some slides on what I'm doing at Nimmy, but I don't think I'm going to fit them into this half hour. If my lightning talk gets voted in, then you'll get to see them then. So the background. Texas Instruments, of course, is a huge manufacturing company that making chips for the most part. But there's a small division within that called the Education Technology Division, and their products are TI calculators. And I'm sure some of you have used those in high school or university, maybe the TI 83, 84. Anybody used a TI Inspire? One, great. Okay, so TI Inspire is the latest, newest kind of calculator that TI has come up with. This picture here is from their website. It shows the whole range of various calculators that they do, and I'm focusing on the TI Inspire technology. That was the piece that I was responsible for doing test automation. In that product line, there's two variants, the CAS, or computer algebra system, where it does algebraic manipulation of the various formulas and things that you enter and gives you an algebraic solution. And then there's the non-CAS or NCAS version, and that does strictly numeric manipulations and numeric answers. And it depends on the teaching style as to which calculator gets used. The platforms, obviously as a calculator manufacturer, they're going to have custom handheld devices that are TI Inspire, CAS and non-CAS devices. And within that, there's many different hardware iterations. They go through cost reductions and those kinds of things. They also have the same application running as a Java Swing application on PC or Mac, and they have an Objective-C implementation that runs on the iPad. And TI Inspire as a calculator is not just a calculator. It has a full document model. Into a document you can insert multiple applications, like a note-taking application, a calculator, of course, some graphing applications, a spreadsheet application, so on. So it's quite the sophisticated calculator. Now, when we do any kind of testing at where I'm involved, we design our keywords as a domain-specific language. And what that means is that we tell through the keyword what to do to the system. We don't say how to do it to the system. How would be things like, push this button, select this menu item. The what is application-oriented things. So I said we had a document model. Insert calculator would be an application-oriented keyword to insert the calculator app into the current document. And by doing that, we can have a single set of keywords that would be applicable to all platforms because it says what to do to the application. And then we let this platform-specific implementations deal with the how do we do it. And so the how is different. When you tap icons, you swipe, whatever, on an iPad. On a Java app, there's a lot of menus and dialogues and those kind of interfaces. And on a handheld calculator, you've got special buttons. So E to the X on a calculator is a specific button. You don't type E and Shift X or anything like that. So they're quite different. How do you do something? And that's handled by a lower layer of software. So that was the environment I was working in, and now the multi-device problem, we had two aspects to that. One was that there were multiple variations of the hardware devices, and they were all available in the market, and so they all needed testing and proving. Mostly due to hardware cost reductions. They change the components, they get a cheaper build. We want to make sure those components don't change the behavior of the system. And we want to test all of those variants at once from Robot Framework. We don't want to have a run for this calculator and then a separate run for the next one and so on. The other scenario with multiple devices is that part of the TI Inspire line of products is a classroom system where the teacher has a Wi-Fi access point, and each calculator has a little hat that you plug on top of it that gives it Wi-Fi capabilities. And then the teacher can send out homework or questionnaires or whatever to the students, and the students can respond with things back to the teacher. In order to test those user scenarios, we needed to be able to drive up to a 40-student classroom of devices, all from one test run, in addition to driving the teacher's desktop computer as well. We also want to be able to introduce some variability in there. So you want to have ways of selecting some students to do things and other students to do something else. For example, the odd number students give an answer A to a question and the even students give an answer B. So we want to be able to not always drive the same commands to every device in the scenario, but selectively choose some of them. So the architecture that we came up with for this is to take a standard Robot Framework device library that we already had when we first started doing single device tests and build on top of that a device multiplexer. And then that device multiplexer is given parameters that tell it how many devices to expect and how to deal with the addressing of them and that sort of thing. And then for all of the devices that it's told to work with and that it discovers via either Wi-Fi or USB, it creates an instance of the standard device library and runs it in a separate thread. And then that multiplexer is using that library to do the work for each device. So we built this using the Robot Framework Dynamic API. Like some other speakers were talking about earlier, that's often an easier interfacing style for Robot Framework. We give the multiplexer a class to multiplex, in this case the device library. And you'll see from other slides later on that we also did this for the desktops, the PCs and Macs as well. That device library is also supporting keywords via a dynamic API. So you've basically got one dynamic API looking at another library and reflecting its keyword methods back up to Robot Framework. And then the multiplexer also adds some of its own keywords. For example, on these devices is a keyword, and it takes as parameters a selector and then another keyword and arguments. And that selector is just anything Robot Framework-ish or Python-ish or whatever that will return a list of device numbers. The device numbers are just like 1 to n for however many devices you have. So if it returns 1, 3, 5, 7, so on, there's your odd numbered devices. And we had keywords to do specific things like random devices, odds and evens, because that was just an easy way to split things up very often. But any test author could write any other expression that, or hard code even, a list of device numbers and address a specific set of devices. Now within this threaded design, each thread, as I mentioned, has an instance of that device library, and the threads in each of those that contain each of those device libraries are coordinated with the multiplexer and the main thread using the threading event. And so inside the run keyword method, which does most of the work, when it's given a command to run a keyword from Robot Framework, it populates per thread data structures that pass that information with the keyword name and the argument name values and so on, passes that down to each thread, and then it sets an event that says, hey, I've got a keyword ready to run, go look at your data structures, all you threads. And then it waits for another threading event that says all the threads are done. So each thread that finishes executing that keyword on the calculator sets a counter or decrements a counter, and when it finally gets down to 0, it says, oh yeah, all the threads are done, and we'll set that event. Once that's done, then the main thread in the multiplexer consolidates the result. It takes any failures from any of the devices, identifies which device had the failure, and puts all that into Robot Framework logging format. And Robot Framework likes keywords to return a value. I mean, obviously you can return none if there is no value, but when there is a value, Robot Framework isn't prepared to deal with 40 values from 40 calculators, so you got to pick one. And we just picked the first one, because in any scenario that we're doing, they should all be the same. We didn't find any problem with that not being able to reflect multiple answers. So, multi-platform. The problem there was, as I mentioned, we had 3 different platforms that supported the TI Nspire application: the handhelds, the PC, Mac, Java applications, and the iPad Objective-C. And because of the way we designed our keywords with the DSL, that we were able to have one set of test cases for the product. And in order to make Robot Framework understand that, we didn't want to plug Robot Framework directly into a handheld or a Java library. We came up with the idea of a proxy product library. And then we had the different implementations for each platform. So what it looked like in an architectural view is, of course, we still used the multiplexers in front of each of the device libraries, desktop libraries, or iPad libraries. But then the part that talked directly to Robot Framework and PyBot was this proxy product library. And it was given configuration parameters at instantiation that told it, well, this test run is for a device or a set of devices, or this test run is for a Windows machine. And it would give addresses and ways of accessing the particular platform that was going to be under test. The proxy product library would then instantiate one of these multiplexers underneath it, pass on the arguments for initializing that particular multiplexer, and then on down through the library layer. Again, we use the Robot Framework Dynamic API for building the proxy product library. And I think I've said all these words already here. we instantiated the multiplexer library. We used the run keyword method in that library to pass on down the stuff from the Robot Framework. So the proxy product library was extremely thin. All it knew was how to deal with configuration, selection, and passing on of parameters so that you could start any one of those three platforms from the same library and reflect back up to Robot Framework through the dynamic API. And that was really important. You may have noticed me standing up when we were talking about users of RIDE. And yeah, we wanted all of that built-in documentation that RIDE gives you for the keywords, and we wanted that to come up correctly from the underlying libraries. So once the product proxy library has instantiated its underlying library and used that dynamic API to figure out what it's running, you would see slightly different support, because although we have this DSL for the product across the whole set of platforms, there's always going to be something that's a little bit different on each platform. And so we use tagging to indicate test cases that were specific to a particular product platform rather than generic for everything. And in the execution parameters, we would be able to select the set of tests that had no tags about the platform and the set of tests that had the right tags for the particular platform that was being run on this particular test run. And we were also able to do some keyword implementations in the proxy library that didn't have anything to do with the platform. For example, TI Inspire has an internal state that is obtainable, at least in a testing environment, as an XML capture. So we were able to capture the internal state of the device or the Java program or whatever in an XML format, and then parse that XML to determine is the calculator in the right state at this moment. And that saved us having to do a lot of screen scraping and dealing with font changes and complicated graph layouts and all that. So it was very nice to be able to write that once as one XML parser capability and then share it across the different instantiations. So I see I've done very well on the time. I've got 12 minutes left. We could go for a lot of questions, or we could go through some of the Nimmy work that I do and shorter questions. So if you've got questions, just give me a hand so that we know how much questions there might be. One? All right, let's just deal with one right now, and then I can do the other little bit.
Well, how did you, when the library you attached to a certain type of device, and did the library then return the right amount of keywords and the right keywords with the right documentation? Or did it always return the same documentation for something else?
That was a challenge to coordinate. What we tried to do was that every keyword that was by name identical had identical documentation. And we just had to because you never knew which one it was going to be pulling it from. So you just had to maintain that multiple times. It was a bit of a pain. And sometimes, we didn't always get it exactly cloned right. But yeah, you picked a sore point.
Right, there's at least one.
Any other questions right now? Yes?
Yeah, no, 1 second. Wait for the microphone.
I can say to the mic. So how did you end up choosing Robot Framework as your test automation tool? Because
before I learned about Robot Framework, I built my own frameworks. And I'd built, 4 or 5 different frameworks for different companies between about 95 and 2008. And when I joined TI, I asked a question of the managers. I said, well, do you want something that requires programming or not? And they said, oh, all of our QA people are programmers. They can all write code. So that was the direction they steered me, and I wrote a Python framework where to write a test case, you had to write Python code. Then, employees change over time, and then they come and go, and there was a new QA director, and he said to me, do we really have to write Python code? Could we do something else? And so I started looking around in the open source market to see what had changed and what might be available. And that was just after Pekka had announced Robot Framework and first made it available. And his architecture and mine were so close that it literally took me 2 days to put the first Robot Framework library together. I basically took a calculator driving Python library and glued a thin Robot Framework layer on top of it, and it was working. And so that was enough of a proof of concept to the new director that I said, yeah, you can do now your tests this way, and we don't have to write code, and we can keep the code writing to the automation team. And so they liked that change of direction, and we used it from 2008 until last year. I don't know what they're doing now. They had a management change and said goodbye to me last year. But I liked Robot Framework so much that when I got into Nimmy, my new company, I asked very explicitly, I said, do you want me to use what you used before, or do you want me to show you something different? And they said, well, the whole product's different. We're developing a new generation. It has nothing to do with the first one from a code and a testing point of view. So I've introduced Robot Framework there. And I think in 7 minutes I can probably go through these 3 little slides and show you what I'm doing there at Nimmy. Yeah?
Same question again.
Same question, requirements traceability. That's one that comes and goes, as you've heard from other speakers. I've done it. I've put in references to various other systems into the test automation system. Before I got into Robot Framework, I was very tightly coupled with Test Director in the framework that I wrote. And the requirements were in Test Director, and the tests was in Test Director, and the test reporting was through Test Director. And when I moved to Robot Framework, I kind of split that apart. And like others have said, there was a half-assed attempt at doing some cross-referencing, but it never proved its value. What did prove the value to us that I haven't heard from other speakers is the bug references. If a test found a bug, then we tagged that test with the bug number, and we used Robot Framework's ability to link into bug systems like we were using Bugzilla at the time. So if you were running a test and it failed because of a bug that was already logged against it, then you would see that bug reference right there in your report, and you could go click on it. We also had filters that would filter out any test that was with an unfixed bug, and we had an interface into Bugzilla so that we could detect that. And so we could stop running the tests that we knew we were going to fail and not have to spend the time troubleshooting them. Once they flipped state and they said, no, developers have fixed that one, then it would come back into the mix, and then we would prove, that test now passes because the bug's been fixed. So 5 minutes.
Are there any other questions?
Any others on the calculator stuff? Okay, here we go. So Nimmy, the product is a wearable band for authentication, security authentication. This is the picture of the Generation 1 band that came out last year, and we're currently working on a Generation 2 that's a little more complicated, a little more features. But the idea is that you through the ECG technology that's mentioned here, and on our new generation, we add to that fingerprint because it turns out that there's about 10% of the population that we can't read the ECG, and I happen to be one of them. You put my finger on one of these bands, you get a band of white noise. It won't read it. So the new generation has multiple ways of identifying an individual person, and once that individual is identified and the band itself is registered to whatever company is using this technology, then through our APIs that we provide to the customers, they can integrate into their security systems and do things like unlocking doors with an NFC reader, or they can unlock your computer with Bluetooth. If you get close to your computer, it'll unlock. You step away, working with somebody else, talking, going for a smoke, whatever, it locks your computer again. And so there's a huge market we're finding for very strict security things like this, where it's a really tedious pain for people to enter their password hundreds of times a day, and doing it this way makes it much more pleasant for the users, and it makes it much more secure for the company, because it's not like a card ID that you could loan or lose or share around or whatever. It's very much tied to the individual. So the particular thing we're doing with our robot framework design for this company is we're always having a robot framework library which is very thin and attached to a product interface which is just generic Python and has nothing to do with robot framework. Because we find that often what we do in testing is useful for other purposes or for other styles of testing. And so if we can do that without having to install robot framework and teach that and just give it to people as a Python module, it has additional value to the company. So every library we've done in those two layers. And there's my last picture of all of the pieces that we're doing. So if you look at the very bottom here, that's the Nimmy band, and there's automation support built into that's driven over USB. And then the host software that we build for the customers to integrate into their security systems have all these 4 layers, and each one of those layers has its own test suite and its own robot framework library to drive it. So we can test each layer individually, and then finally when we get out to the Nimmy API interface, which is the API the customers use, we're testing the end-to-end, the whole product. That's it. I'm sorry I've gone negative a little bit.
It's okay.
But you've got one less lightning talk to worry about now.
Okay.
And open it up for somebody else.
All right. So, big thanks to Martin.